Hi there again. This clip basically will talk about how to explore the data. Exploration of the data is very important to find normality of the distribution, to find missing variable, to find outlier, to choose later on which statistical test, whether parametric or non-parametric, to be used. There is many ways to explore the data. We mentioned before about the chart type, especially the box plot and the histogram for normality. We can explore it either with frequency, the descriptive order, or the explore order, which is the most advanced one. So let us start with the simple one, the frequency. For this set of data, again, you have almost 100 students. You have their result of the test. You have their hours of study before the test, and you have their gender also. So start from the beginning. You want to explore the result and the hour of study, both of them. You go to the variable, you go to the statistics. Now you have mainly two forms of statistics here we are talking about. So we are talking about of the central tendency, which is the mean, median, mode, and the dispersion. How dispersed is your data? So mainly you are looking for the standard deviation, the variance, and standard error of the mean. For distributional, so you have to click for skewness and kurtosis. I will explain it with the chart. It will be more evident. Now, which chart to choose? Use the histogram with the normal curve. Continue. Format, nothing really attractive. Then hit the frequency table. I will show it to you, although it is not very important, the frequency table. So here your result. You have, so this is the frequency. So we have 103 students. You have their of the exam and the time spent before the exam. You have the mean, the median, and the mode, the standard deviation, the variance. Now, skewness is here. Mainly, we are talking about the tail of your histogram. For normally distributed sample should be near 0. So 1 and above is extreme actually. So 0.3 here is acceptable, while 2 here is not acceptable. Kurtosis is the peak of the curve itself. So again, 0 is normally distributed curve. More than that or less. So 4 here is totally abnormal, while 0.8 we can pass it. Now we'll see what I'm talking about with the graph. Now here, this frequency table. That means how many times that value repeated. At the end, you will find the graph, the histogram. This is negative skewness. It is a little bit, it's not that. This is why we can pass the result. And so if the tail here is more, this is the negative side. If it is more here, this is the positive side. But this almost normally distributed. Now you have another one, the time spent for studying, as you can see here, it is positively skewed, and it is not normally distributed. Now the other way to explore your data is with a descriptive. Again, take both of them. Options, mean, minimum, maximum, standard error of mean, variance, standard deviation, skewness, kurtosis, and display order almost the same. However, we don't have the chart here. Now, the most advanced one, and the one actually that have some statistic order for normality of your data, is the explore order. So this, you are looking for the descriptive of the data. Even the outlier, you can tell about the outlier also. Plot, you have the stem and leaf, histogram, and normality plot. This is where you are looking for to assess the normality of your data. Option, listwise and pairwise, I can explain it later on. Then hit OK. You will have the result. Second. Now you can deal with this one. Maybe in the next clip I can explain to you how to try to minimize this abnormality. Taking time a little bit. So the method for reversing the abnormality, you have either the logarithmic one, you have the square root, you have the reciprocal one. Yeah. So let's explore the data. Important to know how many missing we don't have. The results almost the same that we ordered before. This is the extreme value, the outlier that I already. Now here, test of normality, two tests: Kolmogorov, Simonov, and Shapiro-Wilk. Kolmogorov usually is for big data, Shapiro usually for small data. And as you can see here, it is significant, so it is not normally distributed. So what we are looking here actually is something more than 0.05 to say that your data is normally distributed. Histogram again, but without the normality curve. Stem and leaf, as you can see that there is some negativeness here. QQ plot, he will draw your data against the expected values. So if your value is near the expected one, that is normal distributed. But if it is not, you have two plots. You have the quartile and the PP. Second one, then the box plot. This is almost normally distributed, but for the next one, the time spent for revision or studying, it is positively skewed. Then the QQ plot is very disturbed, and as you can see, a lot of outlier, and we'll discuss in the next clip how to deal with this in the normal distribution, whether to choose another test or to do some transformation.